Section 14.3 is adding and subtracting rational expressions with like denominators. So every one of these problems in 14.3, the denominators will be the same, okay? And these problems are a little bit easier because all we really need to do is we need to add or subtract the numbers on top, and the bottom number stays the same. Okay, so for my first problem here, first thing I note, my bottom number is 13, so that's going to stay at 13. Now, I'm going to try to combine my terms at the top by adding them. But, again, I want you to notice that if I look at the top, the first term is an A, the second term is a 9. I cannot actually combine those because they're not like terms. So my answer is just going to be A plus 9 all over 13. I can't simplify it. That's just my answer. Okay. For the second problem, first thing I notice, my denominator is a 3n, so it'll stay a 3n. 4m plus 5m gives me a 9m. Now we can go ahead and reduce 9 and 3. So 3 goes into 9 3 times. 3 goes into 3 once. And so there's my answer, 3m over n. Let's take a look at the next one here. So again, first thing I notice, my denominator is going to be a y minus 2. That's an 8y and that's a 16. They're not like terms, so I'm just going to go ahead and write 8y minus 16. Okay. However, out of the top here, out of 8y minus 16, we can factor out the number 8. And I'm left with a y minus 2. So now, when I come back over here, I notice this y minus 2 and that y minus 2. They'll both cancel out. I'm left with 8 over 1. Remember, 8 divided by 1 is just 8. Okay. Let's take a look at the next problems here. Okay. So y plus 9 here. Now again, I'm going to worry about what I can combine on the top. Well, I can't combine that y on the top with anything, so I'll leave that y alone. I'm going to go ahead and combine the 9 and the minus 5. So 9 plus negative 5 is a positive 4. And at this point, I have to stop. I can't combine anything else. I can't cancel anything else. And that's just my final answer. Okay. All right. So for my next problem, the first thing I want to notice is I already have, again, a common denominator, but I want to go ahead and see if I can factor those out. Again, it's the same denominators. I know that number is a 1, so 1 times negative 15 is a negative 15. I'm looking for two numbers that multiply to negative 15 but add up to a positive 2. So 3 and 5. The bigger number will be positive. That one will be negative. Okay. So I'm just going to write a minus 3 and a plus 5. Notice I'm using a because that's the variable that we have here. Okay. Now on the top, we're going to go ahead and put those together. We can't actually combine them, so it'll just be 4a minus 12. Now I want to go ahead and see if I can factor the top. So out of 4a minus 12, we can factor out the number 4. We're left with an a minus 3. So I'm going to come back over here, and again I notice this a minus 3 and that a minus 3 are exactly the same. So those will cancel out. So I'm left with a 4 on the top and an a plus 5 on the bottom. Okay, great. Okay. Let's try the next one here. So again, first thing I notice, I already have a common denominator of x plus 5. On the top, none of those are like terms, so I'm just going to write x squared plus 9x plus 20. We can factor the top though. 1 times 20 is 20, and the two numbers that multiply to 20 but add up to a 9 are 4 and 5. So that'll leave me with an x plus 4 and an x plus 5. On the bottom, we already have an x plus 5. So So I see that this term here and this piece here, those two factors, are the same. They'll cancel each other out. Again, we're left with x plus 4 over 1, which is the same thing as x plus 4. Okay. Let's try the next couple of problems here and see what we have. All right, so we did a problem similar to this earlier. Again, I want to see if I can factor these bottom parts. So 1 times negative 10 is a negative 10. How about if we use 2 and 5? This piece here is positive, so the bigger number will be positive. That one will be negative. Okay, so now I'm just going to write y minus 2 and y plus 5. Those are the variables that I have, so got to use y's. On the top, we're going to have a 3y minus 6. Looks like we can factor out a 3 out of there. So that's 3 and y minus 2. And then we already have a y minus 2 and a y plus 5 here. Okay. So I notice that this piece here and this piece here are exactly the same. Those factors will cancel out. And we're left with 3 over y plus 5. Let me fix that. It's a little messy. Okay. Come back. Plus 5. There we go. Good. All right. So again here in the next problem, my first step, I want to see if I can factor that. So let's see, negative 6. I need them to add up to a positive 5. How about a negative 1 and a positive 6? Okay. So my denominator is going to be x minus 1 and x plus 6. Okay. Now, I want you to notice that here we're subtracting, but we're subtracting that whole piece. So I'm going to do this in slow motion. I'm going to write 3x minus 1. I'm going to write my negative here. I'm going to put that 2x minus 7 in parentheses because I'm really subtracting the whole thing. And I'm going to think of this minus here as a negative 1. And I'm going to distribute that negative 1 to both those pieces. Okay? So I'll leave my 3x minus 1 alone. Negative 1 times 2x is a negative 2x. Negative 1 times a negative 7 is a positive 7. On the bottom, I still have an x plus 1. Oops, sorry, x minus 1. Let's see. X minus 1 and an x plus 6. Okay. Now we can worry about combining the terms on top. 3x minus 2x is a x. Minus 1 and a plus 7 is a plus 6. Oops, plus 6. Sorry about that. So now I have x minus 1 over x plus 6. Again, this factor here and this factor here are exactly the same. They'll cancel out. So I'm left with a 1 on the top and an x minus 1 all on the bottom. Very good. All right. So let's try the next one. Again, my first step is I want to factor the denominator. So 1 times negative 30 is a negative 30. So if that number is a negative 1, I'll use 5 and a negative 6. So that's an x plus 5 and an x minus 6. Again, I'm subtracting this whole piece here, so I'm going to rewrite that as 2x plus 3 minus, and then parentheses, x minus 2. Okay. Just like we did earlier, I'm going to think about this as a negative 1, and I'm going to distribute that to both pieces. So now I'll have 2x plus 3. Negative 1 times x is a negative 1x. Negative 1 times a negative 2 is a positive 2 over x plus 5. Oops, sorry about that. Come back here. There we go. X plus 5 and an x minus 6. Alright, so now I have my x plus 5, x minus 6 on the bottom. We'll combine our like terms in the top. 2x minus 1x is just an x. A plus 3 and a plus 2 is a plus 5. Now I see this factor and this factor are exactly the same. They will cancel each other out. I'm left with a 1 on the top and an x minus 6 all on the bottom. All right, so that's section 14.3.